Okay, here's a video on center of gravity. Not center of, no, not the center of mass, it's center of gravity. There's a difference, it's subtle, but we're going to use center of gravity. The easiest way is if this is a solid plane, right? You can go to your detailer and you can say, I need to know where the center of gravity is. And he would give you something that's similar to this. So I've got a point mark at 3 size, and I'm going to hit center of gravity. So in AutoCAD, it's called geometric center. So you go down here, you right click on your snaps and hit turn on geometric center. But then you do that and you can end up with the point right there. So that's the easiest way to find the center. But if you don't know how to do that, if you can't do that, that's not an option. Hit the center of this. So let's go measure here, which is better. Why is that acting up? Got some sort of snap setting on there. Turn something off. I'm not sure it's right, but at least it worked. So we're going to go from the center down the center, and this only works if this is uniform. This has no real difference in mass than this leg, right? If you had full sets of stairs on here and an open bay, right, with just angle iron going across it, and this was 2 stringers and just treads, you'd have a different center of gravity. But this is just 2-dimensional uniform. You go from center of this one. The graphics hadn't caught up to the image, so or the image hadn't caught up to the graphics. So we got center to center. Forget this, we don't know that exists yet, right? And then we measured this distance. So we have this length and the distance between the 2 centers. Roughly center. This is the middle, so it seems like it would be balanced, right? If you cut that off and you put it right here, that would be the middle, but you actually get a little bit more arm when it's farther away. So, but then also you have a little tiny difference in arm right here with this little triangle. So, but we're just rigging. We're not sending anybody to the space station. So what we do now is we multiply distance times weight. The distance here, starting from here, is 0 times this is 0. And the distance of 78.1, let's start typing that in, 78.01 times 100.37. And then I'm going to divide that by, I'm going to open the parenthesis, the weight of the both, right? 61.75 plus 100.37, close parenthesis, and then that's going to be give us the dimension from here to the center of gravity. Get 48.29, 49.3. So let's put that there. 49.2967. So let's put a circle right there so we know where that intersects. Control V minus that answer. And that'll give us an intersection. Now that is not exactly the true center of gravity, but for rigging it is what we need. So there's a little difference, right? You can start to see it when you zoom way in. So we're going to hit the intersection of this and this, right? So we're going to hit intersection of that to the center of that, and we end up with 1/8 of an inch difference. Right, not too bad. So, and like I said, that's coming because of the center of mass has actually got a longer arm right here, and then a shorter arm a little closer. So that's where that's coming from. Let's say now what we need to do is run a, and we know this is level when we rig it. That's how we want it to go, at least in this case. If you needed to tumble this, you'd have to attach a sling and a hook right here. Then you could tip it, rotate it. You could do a lot more with it. Let's say you had to bring it up in a shaft, just put a pick and eye right there. That'd be pretty efficient, but then you got to cut the pick and eye off. Center of gravity of a quadrilateral. This is the most common way. It's the way I've seen it done most of my career. And I'll just do the example, Control C, Control V, so you can see the steps. So let's use red. And then what we do is we find the centroid of that. Control K, that's the from this from this corner to the center, from this corner to the center, and from this corner to the center. That you don't need to do the third one, but they all end up in the same spot. So draw point mark, put it on the center there, enter, and then do the same thing on this side. Draw a point mark, and delete all that stuff. I wouldn't maybe delete that red line yet, but then we're going to do this one here in green. And we're going to start do the same thing. Blue. Control K. Draw a couple of points. And then we just delete all that junk. Then we connect the two similar colors. And there you go, that where those intersect. Call it black is draw point mark. Right there, and there we go. So now if we go to, let's change it to purple, to a point, draw a point mark, then hit the center of gravity. Nope, it didn't load up this time. Oh, here it is. It'll be on the same spot, and this will be exactly, because there's no math involved. So you can see they are exactly the same. There's no calculation. It's it's as close as you can measure. So that's how you find the center, and you pick it up from that spot. It's exactly dead center of that plate if the plate is uniform, and that's what I did here. So you can see it looks the same. Another way to do it is let's take the Control C, Control V. This is a little bit faster, whether it was better or not. So let's go like this, enter, and then we have this way. Enter, and then we take this distance, and since it's convex, we're going to run it inside. Then we're going to connect these. I should probably, sorry, like that. Enter, and then this would be, let's do this in green. All right, so we have this. Let's do that in red. And this in orange, and this, it turned to orange, did it? And this, I moved it here, Control C, Control V. So we're just measuring that, and then if it's convex, we're putting it on the inside. Maybe I'll do it, so, and then we do this, triangle here, but this gets chopped off in effect, and the length is over there, and then we do right here, Control K, Control K, Control K, so where those intersect, that's the centroid of that triangle that we created. Draw point mark, F4, enter, and then let's say we change the color to that blue. And we hit draw point mark, point, center of gravity, and we'll end up with exactly the same center. Okay, that's the second way to do it. And then, oh boy, this one here, I don't even want to get into it, man. It's a little trickier. So look at how many lines there are. So you see why I put it last. But you're doing from apex to center to apex. Let's do red. So corner to middle, corner. And then we go from corner to middle. Oh, sorry, to red, corner to middle. So 1. And then 2, so from this corner to middle to corner, and this corner to middle to corner, and this one. So it goes red, green, and blue, and purple, okay? So you're making it from each corner to the opposite center. And then what you do is you connect the, so we're starting out with red. We have, so the center, where the center here and the center here match, this center and this center where they intersect. That one right there. And then we go over here, so the center of this one, the center of that one, where they match. Oh, so I can't tell, maybe there's true, yeah, they all enter the same spot. And then center of this green one. No, let's see, center of this one and the center of this one. I think that's right there. And same thing here, center of this one, center of this one, where they intersect. See why I don't use this one, right? And then what you do is you connect 1, 2, 3, 4, right? Boom, 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 boom. And then you zoom in. So now what we do is we take the actual, it's called center of mass. The no, it would be, anyways, you just to connect the diagonals and right where they intersect. I'm not sure whether language or whatever. Really, I've only done this on paper. So then the same thing happens here is draw point mark, center of gravity, and we'll hit the same spot. And it's exactly 2. There's no bust because there's no math. There's no carrying the decimal place, right? And that's how you get the center of gravity another way. There's many ways to get at it. All right, just one more example. I think I'm going to give you that's a convex quadrilateral. Let's go with the concave. Let's do that in black, and I'll show you where the center of gravity is there. Draw a center mark, and then center of gravity. And we know to locate that one, right? So we're going to go, this one would be red. And then this one's going to get connected through to here. This is red, right? And then this dimension, let's put it in green. Let's take this, and instead of going on the inside, like right there, it's going to go on the outside. So then we take our triangle there, and it's actually here now, right? Then we're going to find the centroid of that, and that'll be the center of our gravity. And I'm telling you what, folks, that's about the best I could do. How to find the center of gravity of a polygon. Obviously, you know how to find the center of gravity of a triangle. It's 1,000 of them on the internet, but it did find one, and it showed me. This is good too because it showed the most common one, which is that, right, where you just divide it up, centroid, divide it the other way, centroid, and then connect them where they intersect. And then, like I said, there's I don't know, 5 or 6 more examples there. So hope that helps you in your career or your teaching. Good luck.